Make me feel it. Class?
Yes.
Woo! Yes. It's almost like you guys excited, rejuvenated. 3-day weekend, you're happy to be back here, including Luke. Isn't that right? Yes, that guy. Yeah, go ahead. All right, graphs and equations. Blah, 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 bunch of words, blah. Here's our function. Now, what we're going to do here is we are going to, yes, this is my pass. Look, see, 704, my pass. And I know, right? Yes. It gives you some reading material while you're on the pooper. Okay. All right, so we're going to graph this by selecting integers starting for x, starting with -3 and ending with 3. So what we're going to do is evaluate this function for each one of these. So I'm going to take my function, which is y equals 4 minus, now the x value, I'm going to put in parentheses because I'm evaluating it, so I'm going to plug that in using a parentheses. -3 close square. Order of operation is super important here. You have to make sure you're putting everything where it goes. I have a negative here. Make sure the negative is in parentheses. Close the parentheses. Make sure the square is there. Everyone on their calculator is doing this right now on your scratch pad, because doing the calculator operations is probably one of the hardest things out of this. It really is. And I'm not trying to be a big meanie about it, but I want to be, but I'm not going to be. It's just keep practicing. That's all you need. Yes. Turn down for what? Oh, turn up. Oh, sorry.
I'm blind, dude. I can't see. I don't know if I can see it.
See, you got to turn up. It's right here. See this right here? Yellow. Control. Plus. All right, you get it. Why are you texting hello? Who are you sending a message to?
Why is there a reference of pi
It is a
flavored
calculator,
pie?
not your Snapchat. Put the numbers that are there. What?
There's a reference to pie flavored pie on there.
Yes. Why do you think it's on my bathroom pass?
I don't know.
Bro, it won't give me an answer.
Well, why do you think it's not?
I don't even know.
Okay, so,
Oh, it's not supposed to give us an answer.
yes it is. Watch this.
Yeah, the square's on the outside of the parentheses.
Now, hey, is it not giving the answer?
No.
It is.
Okay,
-5.
do you put the y in there?
No.
No, you don't put the y in there. So I'm going to have 4 minus, oh that's supposed to be a minus, minus, open parentheses, -3, close, square. So it should read just like this. You can't put the y equals because that is going to be part of the graphing later on. We just want the numerical part, just the numbers. Just the numbers on this. So we're making sure we plug it in the calculator, right? So the calculator's right here. All right, and we come up with an answer of -5. Yes? All right, and since this is a table, I want you to do all of them going down, doing the same steps. So you're going to fill in the y column over here. Y equals 4 minus -2 squared. Y equals 4 minus -1 squared. Y equals 4 minus 0 squared. All right, and dot, 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 dot. Okay. I'm going to come around to make sure you're actually doing this. And that you're not over here just looking at YouTube videos for some reason. I'm telling you, it's all right. You know what? Some people, enjoy summer school after their senior year. Say, don't put the y equals. No y equals. fill out your notes if they're in there somewhere. You having trouble filling out your notes?
No, I'm not even waiting.
Marco, what would
I
we
didn't
do for the lot factors that are not negative?
That are not negative?
Yeah.
Did you get them?
Oh, no, I think the best five is the.
Oh, keep going. Keep going, keep doing them. That's why we're gonna check answers. Where do you think you would find these notes? Hmm? Yes, my notes. Yeah, were you here? Yes. Just so happened to be right here. Look, it's right there. And if someone had their stuff in the wrong spot, it would be. Well, about that.
Let me tell you something.
All right. Okay, you're doing good. Yeah, that's fine. How you doing, Luke?
You're having a bad day.
Just stop typing. Leave it alone.
You have a negative sign, and a sign. There you go. So let's change that number to 1. Up. Change that number to 2. Minus. Okay. Okay. Oh, being too Navy. Why not? As long as it's not Coast Guard. All right, let's go through. Fill this out. Okay. For -2, what's my y value? 0. -1 is?
3,
0 is?
4,
1 is?
3,
Okay, 2 is?
0,
And 3 is?
5.
There we go, right? Okay, so we're going to go through and graph this next. We're going to plot all these points. So it's x comma y. So we're going to go through and plot these right here. So at -3, it was -2,
0,
-1,
3,
0.
4.
Same thing. So 1,
It's reflected.
0. Yes, it is. Can anyone tell me what shape this thing is? Go ahead. Go ahead. Parabola. It is a parabola. So instead of actually messaging on our phone, we could have been plugging these in, right? So parabolas. Huh? Oh, I did? Oh, thank you. See? I was waiting for Victor, but he wasn't paying attention. He didn't catch me on that one. Yep, it's called a parabola. So it's a U shape. So all we did was we plotted all of our points and then connect all the dots. Yeah? Is that pretty easy there? Okay, let's keep going then.
Well, you said it's called a parabola?
Yes. Or if you're going to try and sound it out, it's parabola.
Yeah.
That's kind of like some type of STD. Parabola. That's what you got? Okay. All right. All right, if an equation in two variables x and y yields precisely one value of y for each value x, we say that the y is a function. So this is asking a question, is it a function. And I have an amazing analogy for this. All right. Okay, so let's say throat's kind of dry, so this is horrible. So if your car is going 35 miles per hour on dry pavement, your required stopping distance is 160 feet, or the distance average person walks in 35 seconds. At 65 miles per hour, the distance required is 410 feet, or the distance the same person walks in a minute and a half. Figure A, next slide, shows stopping distance for cars, various speeds on dry roads, wet roads. Figure B on the next slide uses line graph to represent stopping distance at various speeds on dry roads. This is what we're talking about. Yes?
Wait, so it's a car or a person?
We're talking about the car here. But they were giving an example of how far it actually is. So, for you walking at your normal pace for 35 seconds would have been the first analogy, the stopping distance. Does that make sense or no?
So, is that like important for us to know?
No, it's not. It's trying to give you a reference of how far it actually is. So, at the 65 miles per hour, the stopping distance, what they say is like walking for a minute and a half.
Like 100.
Yeah. Yeah, a minute and a half. So it's you have to walk for a while, right? To get the whole stopping distance from driving your vehicle that fast and try to come to complete stop so you don't rear end that person in front of you. Right? So we're gonna have a question. Hey, tell them that during class. The question over here says, use the line graph to estimate a car's required stopping distance at 60 miles per hour on dry pavement. Round to nearest 10 foot. So, let's go over here. We find 60 miles per hour on my graph. We find 60 miles per hour on the graph. Not on YouTube, not picking my nose, we're on the graph. Where's your paper? Where's your paper? It's right there. At least pretend like you're looking at your paper.
Me?
Yes, you.
Oh, right here.
Uh-huh. Yeah. Okay. Find 60 miles an hour, right? Right here. I go up. There we go. And where it crosses my function is right there. So what I'm looking for is, what is the distance when I'm traveling 60 miles an hour? Give me an estimate. 350, 360, right? Looks like it's a little bit more than half. So let's say 360. So it's about 360 feet, right? It's about 360 feet. So with this information right here, we could actually go back and refer to it as a function. It's a function of distance in terms of speed. So I found the speed by plugging in the speed of my graph. By plugging in the speed of my graph, I was able to find my distance, given that, is going to be about 360 feet. Now, let's call it something else this time. Let's reword it. So what if I say, if I had the speed, what would my speed be if my distance is plugged in?
61.
Now, what am I doing with this information here? Flipping them. So instead of actually saying I'm gonna plug in the speed and find the distance, this one I'm plugging in the distance and finding my speed. So if I go back at this, using my distance right here, I come over here and come down here to find the speed. So this is the inverse of the function. So I'm rewriting it to say other information out of it. And that was 60 miles per hour. Is that easy or no? Crazy? It's ridiculous, right? Anyway. And we're gonna stop right here. We're gonna pick up 5B. We'll come. When did I see you again? Thursday. So yes, the next day. All right. So don't forget, like, share, and subscribe. Hit that notification button and support my channel. Buy stuff from my merch store.